So did anyone come out of the memory chapter feeling like they learned something about memory that could actually help them with studying or in any domain of your life where you need to remember something? Do you feel like you got something or learned something new from that?
I really like the mem networks. I thought those were like all the connections were really cool.
Yeah, and that kind of relates to this idea of elaborative rehearsal. So what is elaborative rehearsal again? Who can explain that to me?
Connecting content to other content to make you remember something.
Yeah, good. So when you're trying to remember something, don't just make one single connection and just rely on that connection. If you're trying to remember, oh, Michael, do you have something to say? So I see your mic open. It might just be open. All right, we'll give him a moment. But let's say that you want to learn, let's say that you're in a history class, okay? And in that history class, you need to learn a bunch of details about the Civil War. So they give you a chapter and they say, here's the chapter content, learn this content, you're going to be tested on it a couple of weeks. And let's say that you need to learn specifically a particular battle, okay? Maybe you need to learn about the battle at Fort Sumter, for example. What you could do is you could sit there and you can listen in class and you're going to get some information from class. But then when you sit and you listen to something in class, you're really just building, so that's the initial connection that you're creating. Your teacher's going to introduce you to something. But as you probably have learned, even if you sit in class and you listen to your professor, that doesn't mean that you remember the information. What you usually then have to do is you might go home and you might have taken notes. And so you look at those notes to try to refresh what you've learned in class. But then you could also look at the Wikipedia page for the Battle at Fort Sumter and start reading that. Now what you've done is you've created a second set of connections to the information about Fort Sumter. Then you can go even further and say, go to a reenactment of that battle, which there are plenty of, especially in the right season. I think reenactment season is beginning soon now that it's kind of warming up. So you go to a reenactment, and there you might get presented the same information, but in a different way. And then maybe you might go onto YouTube and you might find a video of the Battle of Fort Sumter. So what you're doing is you're building many, many connections. You're building these memory networks so that if you forget what happened in class, you then have this backup connection from having gone to a reenactment. You have this backup connection from having gone to see a video. This is why it's really effective to take if you can, to take students on field trips, right? Yes, you kind of get in there and you see it, which I think has its own value, but you're supplementing what happens in the classroom. So you're building many of these connections. If one of them fails, you have some backup connections. If you forget what was said in class, maybe you'll remember what was said at the reenactment and then be able to rebuild your memory of class content from that reenactment, from your memory of that reenactment. That's elaborative rehearsal. And I challenge you to really try to apply this to the rest of your classes. I'll say this, I use elaborative rehearsal. If you haven't noticed this already, I use elaborative rehearsal extensively in this class. I find that one of the most ineffective ways of teaching is to just teach chapter by chapter and treat each chapter as this kind of isolated package of information. Imagine how different this class would be if I didn't reference back to the biology chapter, or I didn't reference back to the learning chapter, or I didn't talk about, how psychology is a science, or I didn't talk about cognitive biases or why we need the scientific method. You would have a much less complete image or memory of how all this content relates. That's elaborative rehearsal. I try to connect the new stuff with the stuff that hopefully you already know. And then of course I try to repeat it again and again and again so that it really sticks.
Right. So if you didn't do that, that would all just be short-term memory. So just trying to get through the chapter and then we forget about it.
Exactly. Yeah. Or yeah, you learn it just for the sake of remembering it on the test. Then you take the test and it's like, well, don't need to know that anymore. And some teachers might teach a class in a way that you really don't need to know it anymore, right? But that doesn't serve you. My goal is by the end of this class, even like 6 months, a year, 2 years after you're done with this class, you're going to have this really robust memory of Psych 101. And even if you don't remember the little details, you're going to remember the big picture. And from that big picture, I think you can kind of reassemble the little details. You know, that's when you go and you go, oh, I remember hearing about this in Psych 101. But I know what term to Google. I remember I have to Google the term action potential. What was that again? That's what the goal of this class is. That's what the goal of, I think, really any class should be. Is giving you that framework, that network. All right. So think about this. Use it. I would go over more techniques, but I really want to get through some content. So if anyone is interested in kind of brainstorming ways to improve their study habits that might make their memory more effective, I'm actually happy to talk to you about that. You can email me, we can talk sometime. I think it's really important, and I think that it's something that a lot of teachers don't go over explicitly. I know you just kind of assumed, okay, you know how to study, go study, right? And you might just be studying efficiently. So let me know if you want to talk about that in more detail. But know that that's there. All right. So in that tradition, then, I want to look back at the two really big things that we've learned so far this semester. One, we learned that psychology is the scientific study of behavior mental processes. Okay, remind me again, why does our study of the mind have to be a science? Rather, what advantage is there to studying something scientifically, especially the mind and behavior?
Because the scientific method.
Right, so what does that do for us?
Well, you get a hypothesis and then you test it by like questions and experiments.
Good. So why do we need that method though? What does the scientific method guard against, or what does it prevent us from doing? Because remember that, you know, thinking about your own thought, thinking about why you do something, you can make a lot of guesses, but the scientific method helps you get closer to the real reason why you might be doing something. So what does the scientific method protect against?
It protects against biases.
Good, good. How so? Can anyone give me an example of that? How does the scientific method guard against cognitive biases?
Because like, say, I'm trying to think of an example. Oh my goodness. Hold on, I might be able to think of something and come back.
You're good. Take your time. Anyone else want to jump in there? Anyone catch their own cognitive bias and try to overcome it? How does the scientific method help us avoid cognitive bias? Or avoid certain types of cognitive bias? All right, here's an example. Let's say that you get sick or something, okay? And you hear that essential oils are really good for helping you get over certain types of sicknesses. So what you do is you go out and you buy some essential oils and you use them. I'm not exactly sure how, I think you like dab them in certain places, etc. You use them, and over time, you get better. And so what you might conclude based on your personal experience of how your mind, how your behavior reacted to essential oils, how you got better, you might conclude that essential oils caused you to heal. It helped you. It was medicinal. All right, what's the problem with that?
So it's biased because it's not scientifically proven. So with the scientific experiment, they could test that and do certain groups and doing certain essential oils to see if it's actually true or not. But by just hearing something like saying that they think essential oils make them feel better and then doing it, like their brain like might be like, oh yeah, I feel better. Just like as soon as you said sick, I remembered the chicken noodle soup and Sprite or ginger ale.
So what is the bias there? I mean, why is it a problem? Why is it a problem to rely on your personal experience?
Because it's not always true.
So let's say that you take essential oils and you get better. What else could potentially explain why you got better?
You could have been like almost through the cold if you would have been taking medication or something else that could have helped. I mean, it's a whole bunch of like third variables there.
Okay, good. Third variables. That I think is the really key term here, is when you rely on personal experience, the problem is you may not be aware of all the third variables that are also influencing whatever you're studying. So if you're studying how essential oils improve health, you need to account for or control for those third variables. I think the big one for health is just your immune system, right? So when you take essential oils, while you have those oils, you also have your immune system. So are the oils causing you to get better, or is your immune system causing you to get better? So when you say propose an experiment, the reason experiments help us to determine whether one thing causes another, it's because we're controlling for those third variables. So when you say to make an experimental group and a control group, what you're doing is in both of those groups, those people have functioning immune systems, right? Each person is going to have an immune system fighting off whatever sickness they're experiencing. Then, if you give the experimental group essential oils and you give the control group, say nothing or a placebo, then you know that the only difference between those groups is going to be whether they got essential oils or not. So if you observe a difference between those groups, you know that the only possible explanation is that they received essential oils, because you're controlling for the immune system. That's the problem with personal experience. Absolutely, gut intuitions can be extremely informed, they can be extremely helpful, but they're always imprecise. And so if there is some possibility that the third variable could better explain why something works the way it does, then you can't be sure. So you need the scientific method for that. It helps prevent cognitive bias. It helps control for the third variable problem. All right. Keep this in mind, because we're going to talk about this problem a lot. We're going to talk about this third variable problem and how it really influences our day-to-day, I think in ways that you might not appreciate currently. Okay, the second thing is we learn that the nervous system learns. That is, our nervous system is changing by creating and strengthening a network of neural connections through which you can send those electrical signals. And this is what we call processing information, right? Also being able to predict what's going to happen in the future. So we could say that the purpose of your nervous system is to identify and record patterns. That's what you're doing when you're learning. You're identifying a pattern, and then you're kind of recording it to your memory so that you have it in the future, so that you can use it to predict that something else is going to happen. Well, there's a term for this. This is called patternicity. So if we were to describe what the purpose of your nervous system is, it really is to identify these patterns. It's for identifying meaningful patterns, and that's what we want to identify. When you take essential oils, and it helps you recover from whatever you're suffering from, you hope that if you take the oil and you get better, you hope that that's a meaningful pattern. What would make it meaningful is if those essential oils actually improved your health. Because then in the future you could say, anytime I get sick, I should take essential oils. Therefore, I will get better. The problem is that when you are identifying patterns, there's only a chance that what you identify as a pattern is actually a pattern, is actually a meaningful pattern. It could be that it's a false pattern, that you perceive something that isn't actually real. So you might think, for example, that chicken noodle soup and Sprite makes you better, but that could be a misperception. You could believe it, but it's not actually true. When we do this is actually a tendency that we have. Just anything with a nervous system has this tendency, and this is called apophenia. It's the tendency to mistakenly perceive connections and meaning between unrelated things. We're going to go really far with this word, but I want to start at probably the easiest types, the most easily seen, the most easily perceived types of apophenia. So here, if you look at these images, you'll probably experience apophenia. Over here, we got a little dog, and over here, well, it kind of looks like a dog too, right? It's got an eye here, it's got an eye here, it's got a little snoot coming down. Kind of looks like a mirror image. The reason that we tend to see, so if you're ever just like sitting in a room and you're really bored and you start looking at random shapes and you start seeing stuff, and you especially faces, it turns out we have a very, very well developed, like specialized set of neurons within our brain that are dedicated to recognizing facial expressions. And so the reason it's so easy to see faces in stuff like this, when really it's just a board where it cut into like the knot of a tree, right? And it just happened to make that pattern. But we see a face there because we have a tendency to perceive faces. Our brain just automatically tries to identify faces. That's what you're seeing over here too. You might look at this and kind of see someone like laughing at you, sticking their tongue out and flipping you off, right? Well, that's not actually there, right? What you see is a carabiner attached to something. This might be a piece of leather or like a piece of wood or something, and it's laying flat. Okay, first off, this is not standing up, it's laying flat. It's laying flat on a table, and the rope comes down here, and then another piece is just kind of laying next to it. But because of our tendency to try and find patterns, you put together a pattern here. This is someone laughing at you and flipping you off. How about down here? This is just a collection of toothbrushes. But because of our tendency to find faces, we will tend to kind of look at this as almost like a family of what's that horror Scream, the guy from Scream, like the long white faced mask, kind of looks like a family of Scream. So you can kind of flip between the two, right? You can kind of see the family of faces, but then you can also just kind of see, oh, these are toothbrushes. This is apophenia. You're seeing a pattern here, but they're not real. There are no faces. The only face here is the dog's, right? There are no other faces here, but you perceive faces. That's apophenia. So you're making a connection that isn't real. All right, here's another instance of apophenia that's probably quite familiar. Imagine this. You experience the following on a Monday. The alarm clock does not wake you up, and you're now late for work. The cat has peed on the couch. The coffee maker is making strange noises and doesn't seem to be working. The kids are fighting with each other. It's raining, and on top of everything else, the car won't start. What do you conclude? One or two of these minor irritants would have seemed insignificant or unmemorable. Once the list grows, however, it begins to take shape of a plot of unseen forces perhaps conspiring in a meaningful way against you. I think I've done this. I know I've done this, where, if a couple of things go wrong during the day, you just go, oh, well, I guess that thing's broken. I need to get that fixed, or, oh, I need to do this. But sometimes there are those days when you wake up and it seems like everything's going wrong at once, right? And so when it piles up, the brain has a tendency to think, there must be a reason for this. There must be a cause for why these things are happening. And because of our tendency to find patterns, what we'll do is we'll try to make connections between each of the things that are happening. So here you might build connections between the fact that your alarm clock didn't go off, that the cat peed, that the coffee maker isn't working, that your kids are fighting, and that your car is broken. And you think that's all part of the same thing. Something is causing all of that to happen. The alternative possibility is that each of these things by chance really did just happen on this around the same time. Maybe you've been neglecting your coffee maker, and so it kind of makes sense that it broke. And you've also been neglecting your car, maybe because you're just a kind of person that doesn't like maintaining things. You don't like putting in the effort to make sure they're fixed and running well. So your car breaks down too. And if you're not maintaining your car or your coffee maker well, maybe you're not maintaining your animals well. And so your cat decides today's the day to pee, right? They might already be peeing on stuff. So you have a problem here, right? Is you have all this information at your disposal. Is there a meaningful pattern here? Is someone or something kind of sabotaging you and like breaking all your stuff and getting your cat to pee and irritating your children? Or is it just a bunch of random stuff happening all at once by chance? This can be apophenia too. If you perceive that there's a pattern here when really it's all just random, that would be apophenia. All right, here's another cool one. This one, a lot of people have this experience of angel numbers. So I'll just read this. Do you keep seeing the same number patterns often? They are angel numbers, and here's what they mean. The angels are speaking to you, but instead of using words, they're talking to you through numbers, and here's what they're saying. This article, so angel numbers, the idea is that you might notice that there are certain numbers in your life, certain combinations of numbers that keep appearing to you here and there. A lot of people, and I think this should be good evidence that it's not it's not unique to you. A lot of people experience this, and a lot of people really, I think, kind of find meaning in the number 1111. So if you look at a clock and you see that it's 1111, I know a lot of people, even my brother, who are like, 1111 has like a personal, deep significance. That if I see that number, it means something. Something's about to happen or something did happen. And with my brother, at least, I know what happened was he would notice this number around the time that something else was happening in his life that was significant to him. I think the first time I really heard him talk about this with me was like when he had broken up with like his girlfriend at the time. They had been together for a very, very long time. And so I think he was in this just kind of sensitive, emotional, like kind of not feeling great state of mind. And we'll actually learn about this. Turns out that state of mind, when you're in that, when you feel like things are out of control and you're kind of anxious and you're stressed, you're more likely to see patterns. So I think he was likely kind of noticing this 1111 number because he had that experience. Then in the future, whenever he'd have another experience, he had this tendency to look at the clock and be like, well, you know what? I just had this experience. What time is it? And he would look at it around the time that it was 1111. And so simply having that experience once kind of primed him to look for that number. The reality is you're always finding different combinations of numbers, but you're probably only paying attention to them when they're kind of weird or out of the ordinary, or when something has happened in your life that makes you think, oh, I should look for these special numbers. Now, is there a possibility that there are angel numbers out there and that there's a message hidden in them? Sure. I can't be 100% sure that there isn't, but there's also the possibility that this is better explained by either random chance or the fact that you saw it once and therefore you're going to seek it out again. So there might be, again, a third variable explaining why we pay attention to certain types of numbers. Yeah, Athena.
So I kind of had a similar instance a couple years back. Back when I was working my first job at a gas station, every time I clocked out for 3 days in a row, I kept seeing the same number, 850. 3 days in a row, 850, 850, 850. So I was like, you know what? I gotta play that number for lottery. So I played the number, 850, and unfortunately I played it on the wrong day. Sunday evening, guess what number came out? 850 straight up.
That's funny. Yeah. And it's patterns like it's experiences like that make it really difficult not to buy into it, right? Because you kind of see that number, you take notice of it, you're just thinking about it, and you're just like, you know what? I'll randomly do this. And then sometimes those numbers pop up again, right? This is what's called a pattern detection problem. Maybe there is a pattern here, right? Now, in terms of 850, I don't know. It's just because I'm not a very superstitious person. I can't think of a reason why that would necessarily be a real pattern. But that is the essential problem is this pattern real or is it not real? You're trying to make connections, you're trying to find meaningful patterns. And so I guess the argument that I want to make, and that I have a video I want to show you, and I think that the argument that this video is going to make is that by default, we tend to find meaningful patterns. So you are more likely to believe that you've found a meaningful pattern than you are to believe that you're just seeing a random chance. So that is, we are primed, we have a tendency to attribute meaning to patterns, to things that we see, rather than to assume that they're just chance. And there's a very specific reason why that's the case. Rather than hashing it over here, I'm just going to kind of show this video to you. It's about 17 minutes, so feel free to get comfortable, listen to it. This video, I think, does a very good job of tying together what we've been learning about with what's coming next, with sensation and perception. And it does a good job of explaining how our brains are designed to find patterns and in which situations we do tend to find patterns, even when those patterns are not real. So give me a second. I'm going to bring this up real quick. There we go. Okay. If you, oh, you know what? Hold on. Let me make sure this is working correctly. Share audio. There we go. All right. If for any reason you can't hear this or whatnot, just let me know. All right. Here we go.
So since I was here last in 2006, we discovered that global climate change is turning out to be a pretty serious issue. So we covered that fairly extensively in Skeptic Magazine. We investigate all kinds of scientific and quasi-scientific controversies. But it turns out we don't really have to worry about any of this because the world's going to end in 2012. Another update, you will recall, so I introduced you guys to the Quadro Tracker. It's a like a water dowsing device. It's just a hollow piece of plastic with an antenna that swivels around and you walk around and it points to things. Like if you're looking for marijuana in students' lockers, it'll, like point right to somebody. Oh, sorry. This particular one that was given to me finds golf balls, especially if you're at a golf course and you check under enough bushes. Well, under the category of what's the harm of silly stuff like this device, the ADE 651, was sold to the Iraqi government for $40,000 a piece. It's just like this one, completely worthless, in which it allegedly worked by electrostatic magnetic ion attraction, which translates to pseudoscientific baloney, would be the nice word, in which you string together a bunch of words that sound good, but it does absolutely nothing. In this case, allowing at trespass points, allowing people to go through because your little tracker device said they were okay, actually cost lives. So there is a danger to pseudoscience and believing in this sort of thing. So what I want to talk about today is belief. I want to believe, and you do too. And in fact, I think my thesis here is that belief is the natural state of things. It is the default option. We just believe. We believe all sorts of things. Belief is natural. Disbelief, skepticism, science is not natural. It's more difficult. It's uncomfortable to not believe things. So like Fox Mulder on X-Files, who wants to believe in UFOs, well, we all do. And the reason for that is because we have a belief engine in our brains. Essentially, we are pattern-seeking primates. We connect the dots. A is connected to B, B is connected to C, and sometimes A really is connected to B. And that's called association learning. We find patterns. We make those connections, whether it's Pavlov's dog here associating the sound of the bell with the food, and then he salivates to the sound of the bell, or whether it's a Skinnerian rat in which he's having an association between his behavior and a reward for it, and therefore he repeats the behavior. In fact, what Skinner discovered is that if you put a pigeon in a box like this and he has to press one of these two keys and he tries to figure out what the pattern is and you give him a little reward in the hopper box there. If you just randomly assign rewards such that there is no pattern, they will figure out any kind of pattern, and whatever they were doing just before they got the reward, they repeat that particular pattern. Sometimes it was even spinning around twice counterclockwise, once clockwise, and peck the key twice. And that's called superstition, and that, I'm afraid, we will always have with us. I call this process patternicity, that is, the tendency to find meaningful patterns in both meaningful and meaningless noise. When we do this process, we make two types of errors. A type 1 error, or false positive, is believing a pattern is real when it's not. Our second type of error is a false negative. A type 2 error is not believing a pattern is real when it is. So let's do a thought experiment. You are a hominid 3 million years ago walking on the plains of Africa. Your name is Lucy, okay. And you hear a rustle in the grass. Is it a dangerous predator, or is it just the wind? Your next decision could be the most important one of your life. Well, if you think that the rustle in the grass is a dangerous predator and it turns out it's just the wind, you've made an error in cognition. You made a type 1 error, false positive. But no harm, you just move away, you're more cautious, you're more vigilant. On the other hand, if you believe that the rustle in the grass is just the wind and it turns out it's a dangerous predator, you're lunch. You've just won a Darwin Award. You've been taken out of the gene pool. Now, the problem here is that patternicities will occur whenever the cost of making a type 1 error is less than the cost of making a type 2 error. This is the only equation in the talk, by the way. We have a pattern detection problem. That is, assessing the difference between a type 1 and a type 2 error is highly problematic, especially in split-second life and death situations. So the default position is just believe all patterns are real. All rustles in the grass are dangerous predators and not just the wind. And so I think that we evolved. There was a natural selection for the propensity for our belief engines, our pattern-seeking brain processes, to always find meaningful patterns and infuse them with these sort of predatory or intentional agencies that I'll come back to. So, for example, what do you see here? It's a horse head, that's right. It looks like a horse, must be a horse. That's a pattern. And is it really a horse, or is it more like a frog? See, our pattern detection device, which appears to be located in the anterior cingulate cortex, it's our little sort of detection device there, can be easily fooled, and this is the problem. For example, what do you see here? Yes, of course, it's a cow. Once I prime the brain, it's called cognitive priming. Once I prime the brain to see it, it pops back out again, even without the pattern that I've imposed on it. And what do you see here? Some people see a Dalmatian dog. Yes, there it is. And there's the prime. So when I go back without the prime, your brain already has the model, so you can see it again. What do you see here? Planet Saturn. Yes, that's good. How about here? Just shout out anything you see. That's a good audience, Chris, because there's nothing in this. Well, allegedly, there's nothing. This is an experiment done by Jennifer Whitson at UT Austin on corporate environments and whether uncertain feelings of uncertainty and out of control makes people see illusory patterns. That is, almost everybody sees the planet Saturn. People that are put in a condition of feeling out of control are more likely to see something in this, which is allegedly patternless. In other words, the propensity to feel these or find these patterns goes up when there's a lack of control. For example, baseball players are notoriously superstitious when they're batting, but not so much when they're fielding. Because fielders are successful 90 to 95% of the time. The best batters fail 7 out of 10 times. So their superstitions, their patternicities are all associated with feelings of lack of control and so forth. What do you see in this particular one here, in this field? Anybody see a object there? There actually is something here, but it's degraded. While you're thinking about that, this was an experiment done by Susan Blackmore, a psychologist in England, who showed subjects this degraded image and then ran a correlation between their scores on an ESP test, how much did they believe in the paranormal, supernatural, angels, and so forth. And those who scored high on the ESP scale tended to not only see more patterns in the degraded images, but incorrect patterns. Here is what you show subjects. The fish, it's degraded 20%, 50%, and then the one I showed you, 70%. A similar experiment was done by another British psychologist named Peter Bruegger, who found significantly more patterns, meaningful patterns, were perceived on the right hemisphere via the left visual field than the left hemisphere. So if you present subjects the images such that it's going to end up on the right hemisphere instead of the left, then they're more likely to see patterns than if you put it on the left hemisphere. Our right hemisphere appears to be where a lot of this patternicity occurs. So what we're trying to do is bore into the brain to see where all this happens. Bruegger and his colleague Christine Moore gave subjects L-DOPA. L-DOPA is a drug, as you know, given for treating Parkinson's disease, which is related to a decrease in dopamine. L-DOPA increases dopamine. An increase in dopamine caused subjects to see more patterns than those that did not receive the dopamine. So dopamine appears to be the drug associated with patternicity. In fact, neuroleptic drugs that are used to eliminate psychotic behavior, things like paranoia, delusions, and hallucinations, these are patternicities. They're incorrect patterns. They're false positives. They're type 1 errors. And if you give them drugs that are dopamine antagonists, they go away. That is, you decrease the amount of dopamine, and their tendency to see patterns like that decreases. On the other hand, amphetamines like and cocaine are dopamine agonists. They increase the amount of dopamine. So you're more likely to feel in a euphoric state, creativity, find more patterns. In fact, I saw Robin Williams recently talk about how he thought he was much funnier when he was doing cocaine, when he had that issue, than now. So perhaps more dopamine is related to more creativity. Dopamine, I think, changes our signal-to-noise ratio. That is, how accurate we are in finding patterns. If it's too low, you're more likely to make too many type 2 errors. You miss the real patterns. You don't want to be too skeptical. If you're too skeptical, you miss the really interesting good ideas. Just right, you're creative, and yet you don't fall for too much baloney. Too high, and maybe you see patterns everywhere. Every time somebody looks at you, you think people are staring at you, you think people are talking about you, and if you go too far on that, that's just simply labeled as madness. It's a distinction perhaps we might make between two Nobel laureates, Richard Feynman and John Nash. One sees maybe just the right number of patterns to win a Nobel Prize. The other one also, but maybe too many patterns, and we then call that schizophrenia. So the signal-to-noise ratio then presents us with a pattern detection problem. And of course, you all know exactly what this is, right? And what pattern do you see here? Again, I'm putting your anterior cingulate cortex to the test here, causing you conflicting pattern detections. You know, of course, this is via Uno shoes. These are sandals. Pretty sexy feet, I must say. Maybe a little photoshopped. And of course, the ambiguous figures that seem to flip-flop back and forth. Turns out what you're thinking about a lot influences what you tend to see. And you see the lamp here, I know, because I have lights on here. Of course, thanks to the environmentalist movement, we're all sensitive to the plight of marine mammals. So what you see in this particular ambiguous figure is, of course, the dolphins, right? You see a dolphin here, and there's a dolphin, and there's a dolphin. This is that's a dolphin tail there, guys. If we can give you conflicting data, again, your ACC is going to be going into hyperdrive. If you look down here, it's fine. If you look up here, then you get conflicting data, and then we have to flip the image for you to see that it's a setup. The impossible crate illusion, it's easy to fool the brain in 2D. So you say, oh, come on, Shermer, anybody can do that in a Psych 101 text with a illusion like that. Well, here's the late, great Jerry Andrus's impossible crate illusion in 3D, in which Jerry is standing inside the impossible crate. And he was kind enough to post this and give us the reveal. Of course, camera angle is everything. The photographer is over there, and this board appears to overlap with this one, and this one with that one, and so on. But even when I take it away, the illusion is so powerful because of how our brains are wired to find those certain kinds of patterns. This is a fairly new one that throws us off because of the conflicting patterns of comparing this angle with that angle. In fact, it's the exact same picture side by side. So what you're doing is comparing that angle. It's a fairly new one, that one, and so on. But even when I take it away, the illusion is so powerful because of how our brains are wired to find those certain kinds of patterns. This is a fairly new one that throws us off because of the conflicting patterns of comparing this angle with that angle. In fact, it's the exact same picture side by side. So what you're doing is comparing that angle instead of with this one, but with that one, and so your brain is fooled. Yet again, your pattern detection devices are fooled. Faces are easy to see because we have an additional evolved facial recognition software in our temporal lobes. Here's some faces on the side of a rock. I'm actually not even sure if this might be Photoshop, but anyway, the point is still made. Which one of these looks odd to you? And a quick reaction, which one looks odd? The one on the left. Okay, I'll rotate it so it'll be the one on the right, and you are correct. Fairly famous illusion that was first done with Margaret Thatcher. Now they trade up to politicians every time. Well, why is this happening? Well, we know exactly where it happens, in the temporal lobe, right across, sort of above your ear there, in a little structure called the fusiform gyrus. And there's two types of cells that do this, that record facial features either globally or specifically these large rapid-firing cells. First, look at the general face, so you recognize Obama immediately, and then you notice something quite a little bit odd about the eyes and the mouth, especially when they're upside down. You're engaging that general facial recognition software there. Now, I said back in our little thought experiment, you're a hominid walking on the plains of Africa. Is it just the wind or a dangerous predator? What's the difference between those? Well, a wind is inanimate. A dangerous predator is an intentional agent. And I call this process agenticity. That is the tendency to infuse patterns with meaning, intention, and agency, often invisible beings from the top down. This is an idea that we got from a fellow TEDster here, Dan Dennett, who talked about taking the intentional stance. So it's a type of that expanded to explain, I think, a lot of different things. Souls, spirits, ghosts, gods, demons, angels, aliens, intelligent designers, government conspiracists, and all manner of invisible agents with power and intention are believed to haunt our world and control our lives. I think it's the basis of animism and polytheism and monotheism. It's the belief that aliens are somehow more advanced than us, more moral than us, and the narratives always are that they're coming here to save us and rescue us from on high. The intelligent designer is always portrayed as this super intelligent moral being that comes down to design life. Even the idea that government can rescue us, that's no longer the wave of the future, but that is, I think, a type of agenticity. The projecting somebody up there, big and powerful, will come rescue us. And this is also, I think, the basis of conspiracy theories. There's somebody hiding behind there, pulling the strings, whether it's the Illuminati or the Bilderbergers. But this is a pattern detection problem, isn't it? Some patterns are real and some are not. Was JFK assassinated by a conspiracy or by a lone assassin? Well, if you go there, there's people there on any given day, like when I went there here, showing me where the different shooters were. My favorite one was he was in the manhole, and he popped out at the last second and took that shot. But of course, Lincoln was assassinated by a conspiracy, so we can't just uniformly dismiss all patterns like that, because let's face it, some patterns are real. Some conspiracies really are true. Explains a lot, maybe. And 9/11 as a conspiracy theory. It is a conspiracy. We did a whole issue on it. 19 members of Al-Qaeda plotting to fly planes into buildings constitutes a conspiracy, but that's not what the 9/11 truthers think. They think it was an inside job by the Bush administration. Well, that's a whole nother lecture, but you know how we know that 9/11 was not orchestrated by the Bush administration? Because it worked. So we are natural-born dualists. Our agenticity process comes from the fact that we can enjoy movies like these because we can imagine, in essence, continuing on. We know that if you stimulate the temporal lobe, you can produce a feeling of out-of-body experiences, near-death experiences, which you can do by just touching an electrode to the temporal lobe there. Or you can do it through loss of consciousness by accelerating in a centrifuge. You get a hypoxia or a lower oxygen, and the brain then senses that there's an out-of-body experience. You can use, which I did, went up and did Michael Persinger's God helmet that bombards your temporal lobes with electromagnetic waves, and you get a sense of out-of-body experience. So I'm going to end here with a short video clip that sort of brings all this together. It's just a minute and a half. It ties together all this into the power of expectation and the power of belief. Go ahead and roll it.
All right. Now, unfortunately, I think that the video that he shows afterwards actually doesn't do what he thinks it does. I think it makes things less clear, so I'm just going to skip that. But first impressions, I mean, what are your reactions to this idea of patternicity and its implications? Any initial thoughts or reactions?
Just one thing from the video.
liked like the images that he showed. Like all of them were like kind of like this is what you think, but it's not actually that.
Yeah, I think he does a really good job of kind of of giving really solid examples of these things and just showing how you can trick the mind, right, into seeing patterns that aren't real. Yeah, I like that too. Someone else was about to say something. I forget who it was.
It was me. It was overall that was really cool because it just really tricked our mind into thinking one thing and then it goes actually into something else.
Yeah, I think that, I don't know. I feel like the implication, the reason I really like to focus on the brain as a pattern detection device is not only that that's what it is, but that it really, if you think about the world as just a bunch of information out there that you need to make sense of. I mean, from the moment that you are born as a child into the world, you come pre-equipped with some abilities, right? You know how to cry when you need something. Eventually, your muscles are going to develop. You can kind of stand up on your own accord. Fun fact: you don't really need to teach a child to stand, but if you help it along, it'll do it more quickly. So there are some capacities that we come into the world with, and detecting patterns is one of those capacities. But a lot of just growing up is detecting patterns and hoping that some of them are real and some of them are meaningful and some are going to serve you well, right? If we think back to authority bias, you pick up the pattern that authorities are really good to listen to. Then as you go on, you start to realize, well, that's not always the case. And so the struggle in life is really figuring out what patterns are real and which patterns are not. I think this is something that has come to the forefront of people's thoughts ever since, the concept of fake news has been popularized. To the degree to which if you see something on the internet, can you believe that it's real, right? That's a pattern detection problem. Someone's showing you a pattern and you have to make the decision of, is this real or is it not? And unfortunately, there's not always a clear answer to that, right? And so we kind of have to perpetually live in this middle ground where some things we believe, some things we don't, and some things we just have to kind of sit back and say, I don't know yet. I think for me, that's what I take away from this in general is I think that's just to at least be aware of the fact that your brain works that way, I think can be very powerful. It can be very helpful. Okay. With all this in mind, I want to move on to our next chapter now, which is sensation and perception, which I think is going to help. It's going to describe some of the basic, the foundation of what you need to know to really appreciate how patternicities are created, how you detect patterns. And so I want to say that for most of this class so far, what I've been teaching you is that your nervous system processes information. Well, this is the point in the class where we really start to delve into what that means. You know that it means that electrical signals are sent through neurons to the brain, back to your fingertips to move your muscles. That's what processing information is, but it's a lot more complicated than that. And so here's where we're going to start delving into that detail. Sensation and perception is going to be broken up into 2 weeks. In the first week, we're going to talk about sensation. And sensation is, how does the brain receive information? That is, how do you get stuff that's out here in the world, light, sound, smells, tastes, etc.? How do you take that information that's out here and actually turn it into something that your nervous system understands? For example, how do you take light, the energy of light, and turn it into an electrical signal that your nervous system can transmit through neurons? That has to be really complex, and it is, which is why we're gonna dedicate an entire week to that. So the first week on sensation, how does your brain receive information? Then the following week we'll go over perception, which is how does the brain process patterns of information? That is, once your nervous system has that information, what does it do with it? How exactly does it handle the electricity that's being sent through it and make sense of the world? How do you make sense of the world around you with that information that you've collected through sensation? All right, so to prepare you for this next week, we're going to have to go over a few key terms and concepts. I want to introduce those here. So if sensation is how does the information enter the brain, the first thing we need to understand is that all over your body, you have specialized biological sensory receptors. That is, these are specialized, often kind of their own structures. They've got, they've got their own kinds of cells, their own kinds of proteins. What they are designed to do is they are specialized for converting an energy source into an action potential, or into that neural impulse, into that electricity that your nervous system is going to transmit. So when I say energy, what kinds of energy exist in the world? And I don't mean, when I say energy, I'll say this. I don't mean like that kind of spiritual, metaphysical, oh, energy's all around us. I mean, that is true to some degree. There is energy all around us, but when we say that there's energy, physically, what is energy? What kinds of energy exist in the world? What kinds of energy are you capable of detecting?
Like emotional energy?
So I mean, there is something to be picked up on there. I do think that there is a kind of a concept that is emotional energy. Like when you see someone crying, you yourself can actually kind of start to feel their emotion. But that's not really energy. That's more recognition. It's emotional recognition. If you were to go back to physics class, I mean, physically, what kinds of energy exist?
Like like solar energy and like potential and kinetic energy?
Exactly, yeah. The really basic stuff, light. Light is a type of energy. Light is physically what it is it's a bunch of it's a bunch of photons, and those photons are particles, and they move in a particular pattern. They move in waves, which gives light its properties. And there are many different types of light energy, including kind of the energy that's given off by the sun. Things like infrared light. I mean, visible light is given off by the sun, but so are some other types of light as well. Sound is a type of energy. The things that you taste and you touch, those are all types of energy. Heat is a type of energy. So when I say that you have sensory receptors that are designed to detect certain types of energy and turn it into an electrical impulse that your nervous system can understand, I'm talking about these. So light is visual, and is energy that will be converted into something that your visual system is capable of understanding. Sound is auditory energy. So what sound is, for those of you who don't know, sound is vibrations within the air. So when you drop something on the floor, the impact of it hitting the floor causes vibrations. Those vibrations travel through the air, and then they enter your ear, and in your ear you have sensory receptors dedicated to converting those vibrations into electrical impulses. With light, the sensory receptors are in your eyes. At the very back of your eyes, you have this layer called the retina. And that retina is full of sensory receptors that convert light energy, that convert photons into an electrical impulse. With smell and taste, these are both chemical. This is chemical energy. So you probably learned in physics class that when you have, say, a compound, let's say that you have sodium bound to chlorine, that creates salt, right? Sodium chloride, sodium and chlorine. You have salt there. Well, there's energy contained within the bond between that sodium and that chlorine. So when you would detect energy when you taste something, what you're actually doing is you're literally detecting the energy contained within the bonds between those atoms. So when you eat salt, what's happening is you actually have the taste buds are sensory receptors designed for detecting those chemicals and therefore turn them into electrical signals. With smell, you may not want to, you may not want to think about this, but when you smell something, you actually have hairs, you have they're called cilia. You have specialized hairs within your nasal canal that when that thing that you're smelling, when particles of it bind to those hairs detect and convert the chemicals within that substance into an electrical impulse. Now what that means is, yes, when you smell your favorite food or when you smell your favorite soup or whatever, and you smell that and you're like, I love that, you are literally inhaling particles of that soup and detecting the chemical bonds within that soup. You're detecting the chemical bonds of fat, because fat has a particular set of chemical bonds. Sugar, you might detect sugar, which sugar has a particular set of bonds. And salt, right, NaCl. What that also unfortunately means is that when you walk into a bathroom and it doesn't smell very pleasant, what that means is that there are particles of whatever you are smelling in the air. They enter your nose and physically bind to the hairs inside your nose. And you detect the chemicals that are inside whatever that is. So when you smell something, it is physically entering your body. In case you wanted to think about that.
You're killing me.
I know, I'm sorry, but more information is always better, even if it's information you don't want. With touch, what temperature is? What is temperature? How do you know what makes something hot or cold? You probably learned this in physics class, right? So if something is hotter, what does that tell you about its matter or its atoms? So when you heat up water, what happens to the water?
It boils.
And turns into what? Into vapor, right? So what is vapor if not water that just has a lot of space in between its atoms? When you heat something up, the atoms within that thing get further apart. And when you cool something down, the atoms get closer together, more bunched together. So when you heat up water, it turns into vapor because there's more energy contained between those water molecules. And when it freezes, what that means is the atoms are clustering together and they're much tighter. And so they're cold. They have less energy in there, really. So when you touch something and it feels cold, literally what you're doing is in your skin, you have sensory receptors that are dedicated to detecting how close together the atoms are. If they're really far apart, you detect heat. If they're really close together, you detect cold. So you have sensory receptors dedicated to reading how close or far apart atoms are, which is a really trippy way of thinking about that. Pressure is another thing. Pressure really is when you press your thumb lightly against something, whatever's pressing against it is not doing so with very much force. But when you press down, you can feel the pressure on your thumb because there's more force being exerted against the thumb. So you have sensory receptors that are dedicated to detecting kinetic energy, force. That's pressure. Same with texture. Texture is it's really reading I want to say the word perturbations, but I don't think that word's going to come across well. It's kind of like irregularities. Texture is detecting the irregularities on the surface of something. So when something's really irregular, like sandpaper, you kind of detect that it's really coarse. And when there are no irregularities, that it's really, really smooth, like the surface of your phone, then it feels very smooth. You're detecting the irregularities on the surface of something. Each of these is sensory receptors detecting some type of energy and then making sense of it eventually. All right. Sensory receptors are super important. We're going to be referencing them again and again and again and again. Every organ, we're going to talk about how the eyes work. We're going to talk about how the ears work, how the tongue works, all of that. In each of those cases, we're going to talk about where are those sensory receptors and how do those sensory receptors end up converting their energy, light, sound, etc., into an electrical signal. All right. That's the first term you really need to know. All right, the second thing I really want you to know is something called the just noticeable difference. So I'm going to show you a few terms that kind of describe properties of how your sensory receptors pick up on energy. So here, what this is referring to is it's the amount of change in an energy source. That is, how much light changes, or how much sound changes, or how much a chemical property changes, that is required to actually perceive that change, for your brain to actually detect and make sense of it. All right, so here's my example for you. 2 circles here. Are these the same color or different? Just shout it out. Are these the same color or
Same.
different colors? Okay, they're the same. All right. How about these? Are these the same color or different?
Different.
Okay, they're different. Great, great, great. All right, same or different?
Same.
Same.
All right, same or different?
Same.
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 Okay, same or different?
Same.
Okay, still same. Same or different?
Same.
Same.
All right.
I
I'll have
noticed
you know,
one.
every-
I've seen one with them different.
Okay, can y'all see this? All I'm doing is I'm just flipping between the slides right now. Can you see any change here?
It's literally one shade different.
Yeah, it's like
One
yeah,
itty
it's really
shade.
subtle. It's really subtle. So if you can see this difference here, this is the greatest change. So this is actually, so this slide right here, what I did was the circle on the right is a fair amount of all the other changes I've made in these slides. This is like the greatest change. So this is the greatest difference you'll see, aside from that green circle. Can you see the difference between these two?
Is the left one darker?
The left one is, when it changes, yeah, the left one's always darker. Each of these, okay? You can see that. How about here? Can you see this change?
Yes.
No.
It's very
Now-
slight.
Very slight. I'll confirm that these are the same slides that I've been using. So when you said that you didn't see a change, there actually was a change. And I think you can kind of see that here. I'm just flipping between them. This demonstrates just noticeable difference. So here, these are exactly the same circle, and these are clearly different. Here, what I did was I took that eyedropper of thing, and so if you go into Paint, and you can take the eyedropper, and you can like sample a color, and then change that color. I sampled this color, and then I changed the brightness to just make it ever so slightly, just like a pixel in more light. And so technically, there's a difference between these 2 circles. You can't really see it because it doesn't reach that just noticeable difference. The change in the amount of light energy showing you what color it is, the amount of change in that energy is not large enough for you to actually perceive that change or to see the difference. The only way you really see it is when I really quickly flip through these and you compare them to the other circles. But just looking at this, you'd assume that they're the same. Versus if we go over here, it's much lighter, and so you can kind of very easily see that difference. So the just noticeable difference is the amount of change, let me go back to it for you, the amount of change in an energy source that is required to perceive a change. I think this happens all the time. Chances are, if you play like an instrument or something, unless that instrument is like perfectly, instruments are actually a bad example. Singing. When you sing, you're supposed to hit a certain note. And you might be really well trained to hit the precise note that you need to hit, But chances are, just because your voice box, everyone's voice box is just a little bit imperfect, when you're singing, you're probably close enough to the proper note, even for it to sound like the proper note, even if you're just slightly off a little bit. This is why you can sing in a certain way, and people might not realize that you're quite hitting the correct note. You yourself might realize, oh no, I totally hit a A minor rather than an A flat or something. I don't know. Clearly I don't understand music. But it might be imperceptible to another person that you hit the wrong note. That would be because the difference between the correct note and the note that you sang was not great enough for them to notice. That's the just noticeable difference. So we can talk about visual energy, we can talk about auditory energy, taste energy as well. It's kind of like when you make food and you spice food, you probably don't measure out the exact like granules of salt that you put in something, but you can get it close enough that no one's going to notice the difference between, 30 grains of salt and 32 grains of salt, right? That's the just noticeable difference. Something else you need to know, the absolute threshold. This is the lowest level of stimulation required to perceive a stimulus. So that is, if the stimulation, if that energy source does not surpass the threshold, you do not detect it. There was one time in this class where we talked about thresholds before, and that was when we talked about neurons and how we generate that action potential. So think back to that chart that I showed you, where you're measuring the charge, the electrical charge inside of the neuron, and how it was negative, and how in order for you to generate an impulse, it had to become positive enough that it hit a certain point, and then it would shoot up really quickly, and then come back down really quickly, and then stabilize off again. That point that it had to hit, that was called the threshold. And this is the same thing. If an energy source is not strong enough, if the stimulation is not strong enough that it causes your neuron to hit that threshold, you won't be able to detect it. I'll give you an example. Let's say that you drop a chair and it hits the ground. Chances are you're going to hear that because the impact of that chair creates great enough sound waves, it creates great enough vibrations that when it enters your ear, it's super easy for your ear to pick up on that. However, let's say that you drop a pin, or let's say that you drop a feather. When a feather hits the ground, it does make a sound. You have to be close enough to hear it, but it creates some kind of vibration. It's just that the vibrations might not be strong enough that they actually travel through the air, make it to your ear, and are then picked up by your ear. That would be an example of so if you drop a pin or you drop a feather and you can't hear the impact that it makes, that means that those vibrations did not reach the absolute threshold to hear it. That's important as well to understand. Subliminal perception, sorry for rushing through these, I just want to make sure we get through in time. Subliminal perception, this is being able to detect stimulation even when you're not consciously aware of it. If you think back to our previous chapter, memory, we talked about the cocktail party effect. This is something I mentioned talking about attention. So that is, if you're at a party, there's like background noise, then someone says your name and you go, wait, who said my name? What that shows is that you are constantly monitoring all this information. When people are talking around you, you hear what they're saying. You're actually picking up on that information. But you're going to tune it out unless someone is saying something that you're really interested in, like your name. That's subliminal perception. You are detecting that simulation. You detect that people are talking around you, but you're not consciously aware of the fact that you're picking up on it until someone says your name, for example. All right. Last two terms I want you to know, habituation and sensory adaptation. Habituation is that you will pay less attention to something if it is unchanging. And this is a psychological process. That is, you're allocating less of your selective attention to something. Best example I can give you, imagine a professor, a teacher, who is very monotone, That is, when they're teaching you something, they just do this. Their voice sounds like this. So when they're teaching you about the history of the Civil War and they're talking about the Battle of Fort Sumter, you just really, you're learning about the Confederate and the Union armies and how they met at a certain year, and they're talking like this, and there's really no, fluctuation in their voice whatsoever. It's just this tone the whole time. So there's no energy in it. They're not really putting periods where you think they should be putting periods. And if you listen to me talk like this for long enough, you'd probably get really bored and stop listening to me after a while. That's habituation. When I talk like that, the same way for a long period of time, you're going to pay less attention to me because it's unchanging. This is why I inflect my voice a lot. You probably noticed I get loud and then I get soft and then I kind of like pause and then I go really fast and then I go really slow. The reason for that is I don't want you to stop paying attention to me. So I change the way that I speak so that you don't get bored. That's habituation. Sensory adaptation is very similar, but it's much more biological. So habituation is you're not paying attention to something. Sensory adaptation is the sensory receptors, that is, those little structures that pick up on the energy, they become less responsive the more that you stimulate them. So I'll give you an example. If you're eating your favorite food, the first bite that you take out of your favorite piece of food, it usually tastes really good. You're getting that full impact of all those flavors. Then when you take the second, the third, the fourth bite, the flavor isn't as intense anymore. What's happening is your taste buds are undergoing sensory adaptation. They're becoming less responsive to the stimulation. I realize you got to go, but there's one question here. I want to make sure you know it because I assure you it will be on the exam. The one exception to sensory adaptation is vision. When you stare at something and it's unchanging, it's not like that thing disappears, right? It's not like the sensory receptors in your eyes just kind of get tired of looking at the page and so the page disappears. The reason for that is that your eyes will actually slightly vibrate back and forth. These are called microsaccades. Microsaccades. The next time you're really up close and personal with someone, look at their eyes and try to see their movement. They're not perfectly still. They're usually vibrating slightly back and forth. What this does is that vibration causes the image, the light that's being put on your sensory receptors in your eye, it causes that image to be refreshed. So rather than those sensory receptors getting tired, they're constantly being given slightly different information because the eyes are slightly moving. Those are microsaccades. So every sense undergoes sensory adaptation except vision. Vision does not because of these. All right. I've had you for longer than I'm due, so here's the deal. Everything is posted. This week, we're going to be taking a tour of the sensory organs, the eyes, the structure of the ear, the nose and the tongue, the different somesthetic organs. So we're going to learn that information. Then next week, when we go over perception, we'll figure out how you put all of this stuff together and make sense of it. All right? So if you have questions, everything's there. You know how to reach me. And I hope you have a wonderful rest of your week. Thanks for being here. Take care, everybody.
I got a
Yeah.
question before leave. I remember that you say something about the participation, but like, it's for the end of the semester or like for when?
Yeah, so so there are two components. You need to do 2 online studies and you need to do 2 in-lab studies. The online studies, they're already on Blackboard. And yeah, you need to do them before the end of the semester, so before the final exam. So you can do it anytime up until then. To do the online stuff, if you go into Blackboard and you go into syllabus and course docs, there's a folder in there for research participation. All the links for doing the online studies are right there. So you just find those links, you click on one of them, you follow all the instructions, and then at the very end, you're going to get this personalized code that you need to screenshot and send to me, and then I give you credit.
Okay.
Yeah, and if take a look at that. If you can't find those, let me know, and I'm happy to kind of direct you towards them. Yeah, the in-lab stuff though, that hasn't been posted yet, so that's another professor who's in charge of that. So I'll let you know as soon as that's available.
Okay, that works.
Yeah.
That was my question. Thank you.
Okay, cool. Yep, of course. Have a good one.
You too.